This is Diana Block, your online instructor for business analysis techniques, and this is the lecture video for week 9. And in week 9 we're going to cover a couple of different concepts, the first of which is in chapter 9 of your textbook, and we're looking at some simulation modeling, and there's various concepts under that umbrella, but your homework problem has to relate to minimal spanning. And in a minimal spanning problem, we're trying to cover a certain area using the minimal amount of supplies. In this case problem, we're looking at cables. We're trying to install cable lines into a housing development, and we want to minimize the amount of cable used while covering all of the homes in the area. So this is a problem that could be applied in several different scenarios. And in this one, we're going to look at an example of running cable wire. So with this problem, you're going to go step by step, and you are told to start off with node 13. So we're going to start with node 13 here, and then we're going to follow the steps of a minimal spanning problem to connect all of them. So I'm going to refer you to your textbook. I've got page 339. It's figure 9.6 is on that page, and right above that it has the 4 steps for minimal spanning. Select any node on the network. So we're going to start with node 13. So that's done for us. And then we're going to connect this node to the nearest node that minimizes the total distance. So of all the nodes that are that we have that we could potentially connect to 13, we're going to find the one that is the shortest distance away, that minimizes the total distance. So that's going to be 11, right? So our next step, we're going to have connected nodes 11 and 13. And so then we've got those two connected, and we're going to see which node is closest to either one of those, which next node has the shortest distance. So then we'll add that node on. And we'll continue doing that until we reach the end. So again, look at the instructions right above figure 9.6 on page 339. I'm hoping the page numbers are the same. I'm looking at them on my iPad, so I think the page numbers should be the same. But you select any node on the network, connect that node to the nearest node that minimizes total distance. Then, considering all the nodes that are now connected, find and connect the nearest node that's not connected. So you just repeat that until all of them are connected. So eventually, everything is going to end up over here under the connected nodes, one node at a time. And you can look at the example in the book that I have on table 9.4. Table 9.4 shows you how to fill this information out. So basically, when we start with step 1, the connected nodes are node 13. So everything else is going to be unconnected. The nearest unconnected node is going to be node 11. And so we're going to put the arc, that's the distance here. So in this case, that'd be a 3. And, I'm sorry, we'll put the actual arc 13-11. That's the arc that we're selecting. Then the length of that arc, that's where you've got the 3 here. And the total distance is going to be 3. So as we go through each of the steps, we're going to keep adding up the total distance. So that's how you'll solve this problem. Again, look at table 9-4, because I don't want to talk through all of this because it sounds more confusing than it really is when you listen to it verbally. But if you look at the table 9.4 and the instructions on page 339, the 4 steps, and then apply that to the table on 9.4, you'll see exactly how to fill out this problem 1. Okay? Now, on problem 2, there's quite a bit going on here. So the first things you have to do on problem 2 is calculate probability in this column C. You're going to calculate the probabilities. So you'll remember from earlier lessons, to calculate the probability, you're going to take the frequency that we have here and divide it by the total number. So right now in this problem, we're calculating cars that have come through during operating hours. So the total number of cars is 200. So to get the probability, we're going to divide this frequency by this total. And to get the probability of 5 cars arriving, we'll take this frequency divided by the total. And so we will get all of the probabilities filled in. Once you have the probabilities filled in, then you're going to fill in the probability ranges and the cumulative probability. So let's just guess. I'm not calculating. You're going to do the actual calculations. But let's say if this probability turned out to be 0.5, then anything as far as the lower range from 0 to 0.05, oops, let me do this, would be the range of this probability. And so then when we calculate the next one, the next probability, the lower range would be what the previous step was, right? And then the cumulative would be whatever this probability is plus the prior upper range. That's what's going to go here. So again, when you say it, it sounds more complicated than it really is, but you're going to start off by getting the probabilities here. The lower range, you're going to start at 0 and then add the probability that you just calculated for that row. The next line, the lower, is going to be what was the higher before plus the probability for that frequency level. The next one, the lower, is going to be what the higher was on the previous step plus the probability of that frequency is what you'll put in cumulative. So you're going to accumulate everything here. And so here's your hint. Down when you get to the last one, the cumulative probability should be one whole number, or 100%, because it's going to accumulate everything you've done before. And remember, this probability lower is going to be 0. The lower range is 0, the highest range is 100. So everything falls between 0 and 100%. But start off by doing the probabilities here. Okay, and to get the probability, you take the frequency divided by the total. Okay, so now let's move down to the second half. Now that we've got that information, what you're going to do is you're going to find out what the average number of cars arriving will be. So we're going to take this random number here, and these are going to be probability amounts. So if this random number is 0.753, we're going to find that number in this little table right here. And so wherever that number falls in this table, then that will tell us how many cars will be arriving. That should be arriving for that random probability. So what you're going to put here is a VLOOKUP formula, and we have some additional resources that will show you how to do a VLOOKUP if you've never done that. But you're going to enter a VLOOKUP that's going to tell you to look up this random number in this table, and then the result you want to return is going to be the number in this column. So that's going to be how you'll complete the VLOOKUP. So then you're going to do the same thing over here, except you'll have to come up with the random number. And again, this is all covered in the text. So my video is just telling you where to lay things out. You still have to go through the text to find out how to do a random number. But I'm just going to tell you. You equal random, and then you'll get a random number. And you'll do that all the way down for this side. You're going to come up with your own random numbers all the way down. Yours won't be the same as mine because it's random, remember? And then you'll do the same thing. You're going to do a VLOOKUP to find this random number up in the table and give you the number of cars arriving. Okay, so once you've done that, I told you there's a lot going on in this problem. Once you've done that, you're going to get an average. And you can just equals average of this column. So in here, you'll just put equal average all of this. And then you can do the same thing here. Equal average of this. And then you'll have the average number of cars arriving for these two simulations. So like I said, I know there's a lot going on in this problem. Look up how to do the random numbers. Look up how to do the VLOOKUP. Make sure you do the probabilities correctly because it's going to start there, and put in your ranges here like I explained. If you have any questions about that, just make sure you fill out as much as you can and then give me a call or an email if necessary. And so then on this last problem, we got a lot happening here too, so that's why I want to help you get started. You're going to do some similar probability range like you did on the last problem. So the probability is already given on this one. This is already calculated. So you just need to put in the ranges. So again, the range is going to go from 0 here all the way to 1 here. So you're going to have 0. The cumulative is going to be just this first probability. Then the lower range here is going to be what the prior high probability was, or cumulative was. And then you're going to add the current probability for this step. That'll give you the cumulative. So then the prior cumulative becomes the lower here, and you add to that the probability on this level. So you're going to go from here, starting at 0, all the way to here at 1. And the same thing is happening over here. You're going to just put in the ranges. The probability's already been calculated for you. You're just going to enter the ranges. So then we get down here. What are we doing? We're going to start off with 0 back order, so that's already there. We've got random numbers that are already entered here. So you're going to enter VLOOKUPs. You're going to enter a VLOOKUP right here to get the number of customers for this random probability. So you're going to get the random number of customers by doing a VLOOKUP of this number in this table. And it's going to return to you the number of customers that corresponds with that random probability. So that's what you're going to put in the new customers. So then on your total weighting is going to be any back orders plus your new customers. So on this first line, of course, we don't have any back orders. So you're going to have your back orders plus your new customers is your total weighting. Then we go over to this production possible. We're going to do a VLOOKUP here. We're going to look up this random number in this table and to give us the production possible to put here. So then in actual production, we're going to put the lower of the possible or the total weighting. The lower of the possible or the total weighting. So you can use a formula equal min, M-I-N, equals minimum between this and this. And so then to get our next line of back orders, to get the back orders for the next line, we're going to take the total weighting minus the actual production for the previous day. So the total weighting minus the actual production. If there's anything left, then obviously those are back orders. If we had some weighting and our actual production was less than that, we'll have back orders. So some days you'll have back orders, some days you won't. But back orders is the total weighting minus the actual production goes to the back orders for the next day. Then you just continue filling this out for the rest of the 15 days given. So down here at the bottom, you're going to calculate your average back orders. So you're going to just equals average of this column to get the average back orders. And then to get the gift card budget, let's see, $10 gift card to each customer who's back ordered for 30 days. So to get the gift card budget, we're going to take 30 days times the average back order times $10. So we're going to take 30 days times this number of average back orders we just calculated times the $10 to find out what our gift card budget needs to be. So we're almost out of my 15 minutes. That's how you're going to set up each of these problems. Again, send me what you have if you have questions, and we'll go over it by email. But this should help you get started as long as you read the textbook and look at all the exhibits and information that I gave and the additional videos. I look forward to talking to you in discussion. Have a great week.